For Orient constraints, we're going to focus on the Interp type option. As we can see, under this Orient constraint node, it has some attributes. A very important one here, and one that we don't see in the point constraint node, is this Interp type. What is Interp type? Interp type refers to how Maya blends the driven object's rotation when we have more than one driver object. This option doesn't just exist for Orient constraints. Any constraint related to rotation, like the parent constraint, also has this option, and their principles are all the same. So first, let's see what its options are. There's no flip, average, shortest, longest, and cache. It has these options. Each option corresponds to a different calculation method. Why do we need this Interp type attribute to blend the rotation? Let me give a very simple example. On this 2D panel, I'll draw an angle. What should the value of this angle be? I'm sure many of us would, without thinking, tell me this angle is 45 degrees. But this actually brings up a question. Why do we all think this angle is 45 and not the other way around, 315 degrees? This is a problem we often encounter in the 3D world. When we have an angle, what standard do we use to determine its corresponding value? This is where these Interp type attributes come in. So its corresponding attributes, no flip, average, shortest, longest, cache. The ones we'll see most often are actually these middle three, average, shortest, and longest. Let's talk about them one by one. Average is Maya's default option. If we still remember constraints themselves, when there are multiple driver objects, Maya automatically assigns a weight value to each driver object. Based on this weight value, it will do a weighted distribution for the angle to get the final corresponding angle for the driven object. Now, in the 3D world, this is actually a bit more complicated. Because we have three axes, Maya doesn't just simply average the angle for each axis. If we look at the Maya help documents, we'll see it's actually based on a quaternion averaging algorithm. But anyway, from a practical standpoint, because it's just a simple averaging algorithm, and our rotation we know we're using three XYZ axes, it can run into gimbal lock situations under certain conditions. So when we have two or more driver objects rotating to certain angles, it will often, in some unexpected places, do some very strange flipping. That is a drawback of this average method. So in the vast majority of cases, we don't choose the average method. We should keep that in mind. Next are shortest and longest. These two are also very easy to understand. This is basically what we were just talking about. When we have an angle, which standard do we use to judge its value? If we take the shortest path, that's the 45 degrees. If we take the longest path, that's the 315 degrees. So what is this? It's actually using 0 and 180 degrees as a boundary. For shortest, it's from 0 to 180 degrees. So look, when my angle starts from 0, and I start rotating this way to 180 degrees, it hits a limit. When I go past 180 degrees, it will always choose the path less than 180 degrees. So that's shortest. And for longest, similarly, we use 180 degrees as the baseline. And it goes from 180 to 360 degrees. When we're like this, we're at 180 degrees. When we continue to rotate downwards, note that it always takes the angle greater than 180 degrees. And as we gradually return to this position, it still chooses the angle that goes the long way around, so it ends at 360. Now in our work, in my personal experience, I have never used the longest method, so we can probably just ignore it. So when we have multiple driver objects doing an Orient constraint or a parent constraint, in the vast majority of cases, we're going to choose the shortest option. If we don't have a special reason, we can just go ahead and simply set this Interp type option to shortest. Next, let's talk about cache and no flip. These two are actually a solution Maya provides for better rotation blending. So what are they? When we're rotating, Maya will cache our previous frame. Then it takes the calculated result from the current frame and compares it to the previous frame. If there's a very large angle flip between them, Maya will assume that this angle must have been calculated incorrectly. It will then go back and try to calculate it more accurately. At first glance, this method sounds smarter, like it might give a better result. But there's a problem here. We just mentioned it has to cache the previous frame every single time. So just think, if our scene has a lot of constraint nodes, this caching step will make our rig very slow, because the calculation load increases. Also, because it compares with the previous frame, we only get a previous frame when we are playing an animation. But rigging itself doesn't produce animation. This logic is actually more geared towards simulation, like when we do cloud simulation or particle simulation. It's not really related to rigging itself. So we don't really use these two. We can ignore these as well. So to summarize, Maya defaults to average. This method can easily produce strange results at unexpected angles. So most of the time, we don't use it. Most of the time, we will choose the shortest option. Now let's go back to 3D and see what the shortest and longest options actually look like in 3D. So here, I'm using two driver objects to create an Orient constraint on one driven object. Now under this Orient constraint node, let's change the Interp type from average to shortest. Now watch. When I rotate the driver object, because we know we have two of them, their corresponding weight values are both 1, so each controls 50%. If I rotate this one about 90 degrees, this one will rotate about 45 degrees. Now I'll keep rotating. Look here. When my driver object rotates past 180 degrees, we can see my driven object does a 180-degree flip. The reason for this is because, as we mentioned, shortest always takes the angle less than 180 degrees as its output result. But if we change it to longest, we can see that as we rotate continuously from 0 in this direction, when we pass 180 degrees, it also flips. And this flip is the exact opposite of what we just saw. So if this one is longest and this is shortest, the reason is the same as before. Longest uses 180 degrees as a dividing line and always takes the angle greater than 180 degrees. We also mentioned earlier that when we have multiple driver objects and we're setting the interp type, whether it's for an Orient constraint or the parent constraint we talk about, most of the time we will choose shortest. Some of us might ask, from the behavior, shortest also has a 180-degree flip. And we just mentioned that Maya's default average also has weird flips at certain angles. So why would we choose shortest over average? A very important reason for this is that this 180-degree flip in shortest is more controllable. Because we know that as long as the rotation value exceeds 180 degrees, it will definitely flip. So in our rigging, we just try to avoid situations where a single angle rotates more than 180 degrees. This behavior because we know the condition that causes it when we're setting things up. This is more controllable for us. But the average situation is most of the time unknown to us. We just don't know under what conditions its blending effect will be bad and cause that weird flip. Since we don't know when it will happen, we can't really talk about how to avoid it. So in conclusion, in the vast majority of cases, we choose shortest instead of average.